So chapter 6 is going to be focusing on quadratics. And a lot of quadratics basically deals with equations that involve an x squared. We're going to be looking at some different things like the quadratic formula. We're going to look at how to graph parabolas. We're going to look at different qualities of parabolas, like certain different kinds of equations like standard form and the vertex form. So there's a lot of different things that we're going to be talking about, focusing on, like I said, quadratics. But to begin with, we need to know some basics. Well, as basic is illustrated by this first example, is that if we have something in parentheses, what we have to do is we have to multiply by whatever's immediately outside of it. So if there's a single term here like 4x, I'm going to multiply everything in parentheses by 4x. Now this should be basic review. But what I want to make sure that we talk about is the fact that if I have 4x times x, that's going to be 4x squared. And 4x times, now this is going to be a negative 8, 4x times negative 8 is negative 32. So our answer here for this equation would be 4x squared minus 32. Now let's look at another one. Let's look at this next example for number 3 here. It says 7r plus 1 times 2r plus 2. Now there's two ways we can approach this type of problem. I'm going to show you one way with this first example, then I'm going to get to the next example. I'm going to show you a different method. The first method is more of the traditional approach, and that's using the FOIL method or the extended distributive property, which means that we're going to take this 7r and multiply it times both the terms in the other parentheses. And then I'm going to take the 1 and multiply that times both of the terms in the other parentheses. So to start out with 7r times 2r, that would be 14r squared. And then I take the 7r times the 2 all the way at the end there. 7r times 2 is 14r. Now I'm going to multiply everything by 1. 1 times 2r is just 2r, and 1 times 2 is 2. Now what we're going to do is we're going to combine like terms. So if you notice in the middle here I have 14r plus 2r. So my answer is going to be 14r squared plus those two add together to be 16r plus the 2. So this would be my final answer. Now there's a few problems with doing it in this traditional method using the FOIL property. And is that one thing that people forget to do is take, for example, like the 7r and multiplying that times a 2. Or sometimes we get to problems that are really big, and so having it all linear, meaning all in one straight line like this, makes it a little bit more trickier if you're dealing with a lot of different terms. So let's look at another method that we could use to do this same type of problem. And this method I like to call the window method, or you could say the box method. Now as I start to write this, you might think, oh no, this isn't going to be like the lattice multiplication, is it? No, not quite. It's more like a basic multiplication table, where I'm going to put, let's say, the 6x minus 2 on top. Then I'm going to put negative 2x plus 5 on the side. Doesn't matter where you put them. I could have put the 6x minus 2 on the left side and put the negative 2x plus 5 on the top. Either way, you'd end up with the same answer. Now what we're going to do is we're going to multiply numbers together to fill in these squares. So to fill in this first square, I would take negative 2x times 6x, which is negative 12x squared. To fill in the next box, I take negative 2x times negative 2, well that's a positive 4x. 5 times 6x, well that's 30x. And 5 times negative 2 is negative 10. Now, the next step is to combine like terms. Well, if you notice these two like terms are diagonally across from each other, I'm going to add those together. Now the negative 12x squared does not have any like terms. My answer is going to be negative 12x squared. The 30 and the 4 we would add together to get 34x. Whoops. And then I'm left with the minus 10. So these two methods are the methods you want to use. So personally, I prefer using this window method. It's not very traditional. In fact, a lot of math teachers wouldn't teach it. But I like it because it makes things a lot easier as far as keeping things organized. Now the next thing we're going to talk about is what's called the binomial square theorem. Let's write that down here. And we're going to use this theorem to do these last 4 problems here. This is an important theorem. Now I'm going to write out for you what the actual theorem states, and in a second we'll see how it's applied. So the actual theorem says something like this, that if I have a plus b being squared, my answer is going to be a squared plus 2ab plus b squared. Now what this theorem is saying is that when we have something like this, a plus b squared, we're not going to have just 2 terms. Like if I have, let's say x plus, let's do something simple here, x plus 2 squared. My answer is not x squared plus 4, because we're going to have a total of 3 terms. Now the first term, yes, we do just square whatever the first term in our parentheses is. X, when I square it, does become x squared, so that part's right. The last term is what the last term in parentheses is going to be, squared, so 2, when I square it, does become 4. But I have here a middle term that I would miss it if I did just the x plus 2, and if I just squared those 2 items, I'd be missing this middle term. That middle term, a shortcut way to get it, is to take 2 times the product of a and b. In other words, multiply these 2 terms together. Well, x times 2 is 2x, and then double it. 2x times 2 is 4x. So I would get 4x, x squared plus 4x plus 4. Now let's say if we, because you might be saying, well, where does that middle term come from? Well, let's do this real quickly so you can see where it's coming from. Whoops. X plus 2, when I square it, sorry about that. X plus 2, when I square it, is the same as taking x plus 2 times x plus 2. So remember, when you square something, it means you multiply it by itself. Well, if I use this window method, if I square x times x is x squared, x times 2, that gives me 2x. Go down here, 2 times x, well, that's 2x, and 2 times 2 is 4. So when we simplify this, you get x squared. The 2x plus 2x is 4x plus 4. Which is, if you notice, is what we have over here. Now you do not want to be in the habit of expanding this out and write it out as x plus 2 times x plus 2 and doing the window method here. You want to get in the habit of using this shortcut, the binomial square theorem. Because later on in the book, we're going to be working on, or in this chapter, we're going to be working on problems like this. Where we have to rewrite this in a different form. Well, if I'm having to sit here and rewrite this 3x plus 5 and do this window method, it's going to take me a lot of time, and it's going to be really ugly, and it's not going to be a very easy problem to do. So that's why it's really important at this point that we understand how to use this binomial square theorem. So let's look at another example. So again, the process is that we square the first term. So 3r, when I square it, square both the 3 and the r, so that's going to be 9r squared. Now the middle term is where I multiply these together and then double it. Well, 3r times 1 is just 3r. When I double it, that means I multiply it times 2. So 3r times 1 is 3r, times 2 is 6r. So my middle term is 6r. And then to find my last term, I would just square the 1, and 1 squared is obviously just 1. So 3r plus 1, when you square it, we call this expanding this out, you end up getting 9r squared plus 6r plus 1. Let's try another one. 4n minus 3 quantity squared. Now when there's a minus in there, the same rules apply. The first step is to take and square the first term in parentheses. 4n, when you square it, becomes 16n squared. To find the middle term, we multiply these 2 together and double it. 4n times, but remember this is a negative 3. 4n times negative 3 is negative 12n. Double it, multiply it times 2. So negative 12n times 2 is negative 24n. Now I just take and square the negative 3. When I square negative 3, that becomes a positive 9, because negative 3 times negative 3 is a positive 9. And that would be my answer. So it's a pretty easy process. Now I want you guys to try these last 2 on your own, for examples 7 and 8. So I want you guys to pause the video and hit play when you're ready to check your answer. Okay, let's see how you did. So the first step here would be to square the 8r. 8 and the r, when you square it, becomes 64r squared. Multiply 8r times 3. Well, 8 times 3 is 24. So this would be 24r. Double it, so when I take 24r times 2, that's going to be 48r. And then square the 3. 3 squared is 9. And lastly, looking at this one, we would start by squaring the 6b. 6b when you square it is 36b squared. Take the 6b and the negative 5, multiply those together, but remember it's a negative 5, so 6b times negative 5 would be a negative 30b. Double that, and it's negative 60b. My last term is negative 5 squared, which is a positive 25. So hopefully you got these right. And again, the key from this lesson is making sure that you are familiar with this binomial square theorem and how to use it. And as far as if you have, but the only time that you can use that binomial square theorem is when you see things written like this, where you have two terms in parentheses. That's why it's called a binomial. Bi means two, so we have two terms in parentheses being squared. You can't use it on a situation like this one. Here you have to use either the window method like I showed you, or use a more traditional approach, which would be the FOIL or the extended distributive property. So with that, I hope you understand everything, and good luck on your assignment.